This will be the first video in a series of videos on how to attach a home addition to a house, something like this. And I'm going to do a couple of different projects like these, and I'll eventually have all the links tied together on the website. But in this one here, we're just going to go over how we would design the home addition. So we're going to put one off to the side here. Something like this. We're going to have a sliding glass door, some corner windows, and I'm simply going to use trusses here. I'm going to make it as easy as possible for the first project that I'm going to walk you all the way through. I'm going to do the foundation and the framing, and on something like this I might even do the drywall, give you an idea how to do the drywall electrical, and even the siding or stucco, but no guarantees. I'll see how it goes. I mean, if there's an interest in this, I'll walk you through more of it. If there's not much of an interest in it, I'm just going to provide you with the framing and the foundation, and which is what most people need help with anyway. So here we have a gable roof that would look something like this here. And this would probably be the most effective and easiest home addition again. Just some regular trusses going all the way back, not too complicated. But we could also do a hip roof on the end, if that's something that you're looking for, even though it wouldn't match the architecture of the building. I do have to point out that hip roofs allow you to put less stucco on or siding around your building. Sometimes it's easier to build instead of getting some scaffolding and coming up here and doing the upper section of the gable. So I'm just kind of throwing that out there. And here's what the floor plan would look like. I moved the windows to get rid of the corner windows, centered them in the room, and then put a door over here. And of course, you can always build a shed roof. That would just be continuing the roof all the way through. And I did put a window in. It kind of looks like the window and the door are in the way, in each other's way here, but this window is actually above the door, which would look something like this. And again, this window can always be longer. It could be 2 windows with a post in the center of it. And there's our shed roof there. So the shed roof isn't going to be the same. You're not going to be able to do it the same as the truss roof. You might need larger rafters, which would mess this area up here. If you have a 2x4 truss roof or a 2x6 kind of rafters here, and then you're going to need to add 2x10 rafters. And it could force you to lower the wall here so that the top of the roof would blend in together. Just throwing that out there. Or have the wall at the same height, and then you would just have a piece of fascia board on the side here. That would be up to you. Just another thing to consider when designing a room addition. And I understand a lot of people, it's like what I'm saying just going over their head. You know, you'd figure it out eventually once you got to that point. You know, if you need more detail on something like that, let me know. I am going to do, like I said, a variety of different videos on home additions, different projects, and to give people an idea how you could actually build something like this. And eventually I'll get to this, I would imagine anyway. But this is the home addition I will be providing you with more information on. Just a simple living room addition extension. Sliding glass door and a couple of windows. So this is the end of this part. The next part will be the foundation, and then I will do at least the framing on it, and all of the framing will be done at once, the roof and the walls, since it's not going to be that big of a project. In this video, I will provide you with some information on how you can build a concrete slab for this particular project, for this 12-foot by 12-foot home addition. Now, it's not going to be a short video, so bear with me. I tried to put a lot of detail into it, and think I did. Trust me, drew enough stuff here this morning. So first thing that I would do, and this is normally what I would do, If it's a concrete foundation, raised floor, I would just simply grab a straight board and kind of put it across here like this to give me some kind of a line that I could follow. And you could always use a string too. And you can see here where it kind of creates a square. And you can always double check it with the 3, 4, 5 rule. And I will put a link in here to that video that I have already made. And we also can check it by cross squaring it. And I think I have a video for that also. So here is the outline for the addition. By putting this board here, it will allow you to measure in both directions. So you're going to be able to get the measurement that you need from here, from the outside edge of the foundation to the outside edge of the other foundation. And of course, the other side here, you'll be able to get it from the foundation. Now, I'm not suggesting that you're going to be able to get these measurements precisely. You might have some stucco on the outside or some concrete. You know, this concrete could have a bow in it, or could be in a little bit, or just kind of zigzagging through here. So you're going to have to double check the measurements here. And you can usually do that. Once you get your boards in place, you can measure from this point to this point, and then from this point to this point, and they need to be exactly the same to create a square structure. Now keep in mind that there are other ways to do this. This is just something that I used that worked for me whenever I was doing a room addition. So once you get the boards in place where you want them to be, you can start digging your footings. And I used to just simply, I would have the board here as a guide board, and I would just kind of draw a line in the dirt, here, and then take this board and set it to the side, dig my footing, and then do the same thing all the way around here. So, you can do it. You can leave the board here. You can fasten it in place with stakes. You can do what you want. But remember, these are just going to be guide boards. And the footing is going to be 12 inches by 12 inches, and that's in the ground. So this is considerably lower than the top of the footing. We're going to have to fill this area in. You'll see that here in a little bit. I also like to dig a little bit underneath the existing footing if it works out that way. If the existing footing is below the new footing, I don't worry about it. I'll let the epoxy rebars handle everything. So if it's case, this just kind of gives it a little key. That's what we used to call it. I don't know if they still call it that. Maybe you guys can let us know what you call it. Leave a comment in the comment area. And this just kind of allows a little bit of the concrete to go under here. And then if this footing here was ever to push up somehow, or if this one here was ever to settle down, it gives it some type of a pressure point to give it some additional strength. After the footings are dug, you can start setting the forms. And again, you can do this, and you can start from over here. You can start from in here. I'm just starting from this side and then going to work my way around. And I usually let the form board go a little past over here. You can have it stop right here if you want, but this kind of prevents the concrete from spilling out if that was ever going to happen. Gives you a little additional support there. And then I'm just going to drive one stake in the ground. You can drive a couple if you want. You could even put a couple at an angle here, whatever you need to support everything. But I don't want to put all the stakes in until I have everything right where I want it. And then you can see here where it lines up with that. Now I need to point out something. The soil here, you're probably going to have to dig it a little further this way. If you dig it even with this and you go to drive your stakes in, the stakes are probably going to cave the soil in. I'm not saying it's going to be a big deal, or it could be a big deal, but I used to always dig my footings a little bit farther. I would dig them to the other side of the stake, and maybe even a ½ inch larger than that. So I'm just kind of throwing that out there as an additional bonus, something to think about. So can you have the footing 12 inches, from the inside of this? Yes. Can it be from the other side? So let's say that I add 2 inches to the side of this, and then I only make my footing from the face of this 10 inches. The inspector might not buy it. I would just make the footing 14 or 15 inches wide and not worry about it. They're going to be looking at it from right here. But again, this is also going to depend upon your building inspector. Next board, everything needs to be level, of course. Next board, you set it with a couple. Now you don't really need this. You can nail this or screw this into this board here, and then just put this stake in over here if you want. And then our last form board. And after you have everything where you want it, you can put all of your stakes in, and I like to space them no more than 3 foot on center. For a project like this, you might be able to go a little farther, but why risk it? You want to make sure these things are nice and solid when you're pouring your concrete. I have seen them move plenty of times because there weren't enough stakes in the ground here. And you don't have to have your stakes that go vertically into the ground. You don't need to have them next to these ones here that are angled. These can always move over a little bit. I just have it in here because it was easy to draw that way. I can actually connect these parts together and put them all over the place. And the purpose of the angled stakes are to get a nice straight line here. And I realize I'm not going to be able to provide you with every single step in this video on how to build something like this, but you can tie a string from right here and then tie it from over here and then get it nice and tight and then actually pull the board or push it over and make sure that it lines up with the string to get a nice straight surface. On a 12 foot by 12 foot room addition like this, you want to have it nice and straight, but it's not going to be as critical as if you had a 30 foot wall here. You're going to have to make sure it's nice and straight, and that's where the string comes in for that. So stakes, you can get these at your local home improvement center or lumber yard. And then of course we're using duplex nails. And you can use 8Ds. I've seen a lot of people use them. I actually like to use the 6Ds, a little smaller nail. I've had the 8D nails actually split the stakes if you have a drier stake. And so I just put a few more of the 6s in to make up. But again, you can use whatever nails you want for that. And again, this is where the board, when it goes past, it creates a nice barrier to block this. If I had it even, with this right here, and you're pouring this and it just opens up a little bit, then the concrete's going to flow out. I'm not saying that it won't flow out in between the crack if it's longer, but again, this is something that works well, and whenever you can do it, use this, try and use it. Next up on the list, we will need to drill some holes for some dowels, and in this case we're going to make them 6 inches deep. They need to be a little bit larger than the rebar, and I'm not going to provide you with step-by-step instructions on how to dowel everything. I think I do have a video for that. I will put a link to it, and if not, there are plenty of videos available on the internet for that. I am going to position them in the center here, and it needs to be, I believe, no more than 3 inches from the exposed concrete, top of the concrete. You can even go 4 inches if you have the room, and then maybe 3 inches down at the top. Now these here, and I have them lined up here, I'm going to have a 5-inch wide concrete slab, and it wouldn't be a bad idea. I don't want to say that you need to center these, but you would probably want to center the top of it, because you're going to be putting another piece of rebar on top of this, and you don't want it to get too close to the top of the surface, and you don't want it to be too close to the soil. And I believe we need to be at least 2 inches away from exposed soil for that. So we got plenty of room. If you're pouring a 4-inch wide slab, this could actually be a problem to do something like this. And you might want to go with the 6-inch, I believe it's number 10 wire mesh. If you're going to do something like that, that might actually work better on a 4-inch slab. But again, this is something that an architect might not address. He draws in a 4-inch slab, and the engineer puts the rebar in, and that's the end of it. You guys are going to have to deal with the rest of it. So since this is my project, I get to do what I want. So we are putting them at least 2.5 inches to the top of the lower rebar. Now you are going to have to put some fill in here. What you're going to use, I can't really advise you on that. I know a lot of people use gravel. Only problem I have with gravel is that when you go to put the visqueen on top of it, it can actually tear it over time. So maybe a fill would be fine, some type of a fill material, an approved fill material in your area. You could always contact a local landscape supply place for that. So, and then you put some visqueen, 6mm visqueen. Now you can pour your new home edition foundation. You can pour it right on top of the dirt, no biggie. You know, in here, I'm putting this in here because the footing was considerably higher than the exterior ground level. And again, I have plenty of videos on showing you how to, you know, the soil that's 6 inches down. This is another, gives me a chance to create another scenario to keep you viewers coming back for more, you know. So if I drew everything the same, you'd be like, I've seen that before. And then on top, some sand. 1 inch of sand is usually the minimum required to in between on top of the visqueen, so it'd give you an idea there. And then we would have 5 inches from the top of the existing house foundation to the top of the sand. Next up on the list will be to epoxy the rebar into the existing foundation, and we're going to have one on the bottom on each side and then run a row across here, 16 inches on center, and then I just space this one a little bit farther. You could always equally divide them up to have them a little less than 16 inches on center so that they go equal distances from here to here, or just simply put one in the middle here. I just left it out and hope the inspector didn't like it or likes it, approves of it. So there's not going to be an inspector on this job. I don't have to worry about it. I can actually just do what I want, and I just approve this, so that's the end of that. So all of these rebars will be the same size. They're number 4 bars. They're sitting on top of little concrete blocks. These are concrete spacer blocks, and you can also use them if you need to on the bars in the footings, and kind of give you an idea what we're doing here. And they were going 6 inches in, I believe, the rebar. And don't forget, the hole on the concrete needs to be a little bit larger most of the time. Now, I actually, when I first started doing room additions, we didn't have epoxy, or if they did, it wasn't readily available. We used to take and drill a 1/2 inch hole and then drive the 1/2 inch rebar into it. And of course, the rebar would prevent the slab from rising or sinking. And if you put it in at an angle, if we drilled a hole at an angle and then drove the rebar in and then bent it down, it would also give you a little bit of strength for preventing it from separating from the existing concrete slab. So just kind of throwing out some different views here. Take a look at the stake. Just drive a stake in, put a nail in it, and then wire the rebar to it. And this is just going to be temporary. Eventually, we will use the other rebar to help support this. And of course, we can use some boards for on the forms to help hold it up also. Here are the little blocks. We used to call these dobies. I don't know where the word came from. If you do, feel free to share it with us. And we just cut all the rebar the same size. And these, of course, are running this way. And next up on the list would be to install the rebar running this way. Again, 16 inches on center. And it is going on top. And you can get a pretty good idea why I wanted this in the middle right here. So this top of this rebar, if it's in the middle, then these both of these will be about 2¼ inches away, I'm guessing, from the top here. And feel free to correct me on my math there. But if 2 inches is the minimum, and you have an inch in here, then it's probably going to be 2 inches. That's probably more of where I'm at here, not 2¼ 2 inches. And if that's the minimum distance for rebar, then you're going to have to make sure that you figure that out. Like I said, 4-inch slab just might not work. So here they are lining up. The rebar lapping here. And for number 4 rebar, this needs to lap at least 20 inches minimum. And here it's being held up by the support stake that we put in the ground. A view from above. You can see here where this is going. The one on the bottom is lapping the same exact way there. Coming the same on this side over here. And that is it for our rebar. Now let's go ahead and install our anchor bolts and the support braces that are going to be holding them up. And you can actually purchase these. They have some support braces, plastic. I don't know if they have them out of metal. I think they do, but you can get those, or just take and grab a piece of scrap wood and then drill a hole in it and position it accordingly. So the anchor bolt, the center of the anchor bolt, should be in the center of the wall. So if we have a 2x4 wall, it's going to be 1 3/4 in to the center of the anchor bolt. And then, of course, you're not going to need the washer on top. Some of my videos have the washer on top because this is a pre-made component I can use as part of my drawings. So, and then the anchor bolt does need to be high enough. You're going to need to allow for the 1.5-inch plate if that's what you're using. If you're using a 3x plate, you're going to have to add 2.5 inches. Now, the anchor bolt usually has a minimum embedment, and let's just say 7 inches is kind of a standard. It can be deeper. It just can't be smaller. So if you were going to use a 12-inch anchor bolt for something like this, you'd probably be fine. But if you're not exactly sure, get a 14-inch or a 16-inch, and you'd be fine with that. So 7 inches would be from the top of the form, top of the foundation, to the bottom of the anchor bolt. So give that an idea. And again, I don't know if that's actually from the top of the anchor bolt where it bends instead of the bottom. So if anybody has any clue on that, feel free to share it with me. I've always made sure that my anchor bolts were longer, so I didn't have to deal with that. It wasn't too difficult. I'd go down to the lumber yard, and they would have 12-inch, 14-inch, 16-inch anchor bolts. I would just get the 14 inches for something like this, and the embedment was, about 8 or 9 inches. I was fine with it. So here is the temporary brace again, anchor bolts in the corner. We will be removing this once we get over to this side here. And I'm just simply going to put a stake or a piece of scrap wood, and you can always nail it to the top of the forms. And you can use this to hang the rebar. I can simply run some wire, and I would probably drive a duplex nail in or a screw here and here. I've done this before where I've wired it up and thought that it wouldn't move, and it did move. So make sure that you have a nail into the forms and a nail where the wire is, or something at least, to prevent the wire and the rebar from moving. So this way you could hang it from here and then get rid of the support brace. And you can see here where we can actually connect the top of the rebar here to this one here. Let's go ahead and get rid of our support brace. If I wire this and then run some wire down, wrap it around here, then this cantilever here will actually support this. Now, I'm not suggesting that it's going to do it all the time. And if that's the case, you might need to put another brace up on top or run some wire from the top of this. Drive a duplex nail into here and then have the wire come down, and then do the same on the other side. If I just put it on this side, it's going to want to pull the rebar this way. But if I put it on this side and then go to the other side and do the same thing, I can pull it over and pull it up. And then, of course, once the concrete is drying, I can just simply cut the wire. And that will be that. So that is it for this video here. Rebar, anchor bolts, footings, Simply pour the concrete in here, strip the forms, and then you are ready to start framing. And anchor bolts, of course, I didn't go over the positioning on them, where they need to be positioned, but they do need to be positioned to where they're going to miss the wall framing studs. You're going to see more of that in the next video. So if you were going to build something like this and you were going to follow the instructions for this, then let me know. And again, keep in mind, this is just a project that I kind of made up here off of projects I've done in the past. This might not work in your area. I have got to say, I can't say that enough. For example, just this morning, someone asked me to provide them with engineering specifications. I am not an engineer. I'm just, all these videos are based off of my experience or things that I have seen built and approved by engineers and city building officials. But again, I live in Southern California. So there aren't no snow loads here I don't have to deal with. I don't have to deal with any frost lines. If you're going to build something like this in an area where the ground freezes, you might have to have 5-foot deep footings. You're going to have to go below the frost line. So again, this is just an idea of how something like this can be constructed. It is not, I'm not suggesting that you can use this in every part of the world, and it's going to work and you're never going to have any problem with it. Always consult local building authorities, contractors, engineers who are familiar with your area. Welcome to our third video in the series for building this small 12 by 12 room addition. And we have the anchor bolts and the concrete slab. Now I wanted to show you that, you don't have to do this first, but you're not going to be able to frame your walls most of the time with the fascia board in the way. So you're going to have to remove a section of the fascia board. And that's probably going to be one of the first things you do. And another thing you might want to do, but you don't have to do, will be to remove some of the roof sheathing. If you have a little piece like this, take it off. And this is where we're going to cut our fascia board. Now you don't have to remove this. If you're going to use the existing roof shingles, you can always stop it right here. That's not going to be too big of a deal. You might have to later on take and remove some of the roofing because you might need to install some straps. And I'll cover more of that in the roofing section. Now, the fascia board here, the reason why I'm not taking it, I'm not taking all of it off, is because we can cut it somewhere here. If I go to the middle here and I just stay a little bit over, and again, you could always cut this right here, but I'm going to be cutting this at an angle. I just don't know where I'm going to cut it at. And I have no desire to figure it out mathematically when I can build my walls, put the rafters up there, and simply mark it and cut it. So that's the theory behind that, and the reason why we are only taking off a section of it, and a section of it that's just going to be in our way. Now this won't always be the case, but you might have one of the lookouts kind of in the way of the wall, something like that, and you can simply cut that off. But you don't have to cut these off all of the time, because it could actually provide you with some structural support for your roof also. So you don't need to put a rafter up against here, but if you are going to put a rafter up against the wall here, you can always cut these off on this side. But again, I wouldn't get carried away cutting too many things out of your way before you realize that they are vital parts of something that you need to connect another piece of framing materials to in the future. So again, you can look at this room addition if you're going to build something exactly like it and follow it. You're not going to have a problem with that. But if you're building something similar to this, then I really would advise, if you don't know what you're cutting, try not to cut it until it needs to be cut. And you're also going to need to have some type of a temporary support to hold up the roof truss. In this case, we can always go to the outside You're going to need to make sure that this stuff is far enough away from the original framing so that it's not in your way. That's going to be another thing to constantly think about while you're working on your home addition. Now I'm also going to put some boards here, some support boards, and I'm going to screw it into the roof truss. Just put some screws in there, and I'm not providing you with a bunch of nailing and screwing detailed information because these are just meant to be examples. So what I did here was put some screws in. I got 6. You might want to put 10. You might want to put some. You might want to drill a hole and put a bolt in there. To where you have a bolt and a washer or something like that. You might want to use larger lumber depending upon the weight of the roof. If you have composition shingles up here, that's not going to be that big of a deal, and you might not even need to put these support boards in. You have tile up there, it's going to be definitely a thing that you're going to need to do. And here I just kind of space these out here. I'm going to have this board in here, so I just kind of equally space them out there. And then we can go ahead and remove our wall framing studs. And again, these boards are out of the way. We're going to put a beam in here. And if I was to put these boards or leave a couple of the support boards underneath, then you could see where it wouldn't work, wouldn't be able to get the beam in there. So keep that in mind. And let's go ahead and remove the corner section here. And of course, this will be the area where we're going to put our support post. I'm going to put a 4x4 in there, give you an idea of what this would look like. You're going to have to cut this also if necessary. Got to make room for the beam. Our supported boards. And I would recommend doing all of this if you can in one day. Remove the wall, get the support beam under there. That way you don't have to worry about the house falling down. And I always try to get all this stuff done as soon as possible. Hated to have an existing house hanging there, in case something happened, earthquake, at least I'd have my support post in there. Now I do want to point out that, and I've done this before in some of my other videos, if you don't need to just stop. This one here, you're going to need to stop it here. This one here, the beam can actually go into the wall a little bit. So I'm actually just going to stop it at the next framing stud. So if the next framing stud was here, let's say, I would stop it at this one and just run the beam all the way through if you have enough materials. If from here to here is 14 feet, then put another wall framing stud in here and then use your 14-foot beam. If from here to here is 13 foot 8, cut the beam, run it to here, and use the full length of the beam. Have it run past a little bit. I've done this before in garage framing, and it seems to provide some additional structural support. Now let's go ahead and put our beam in. We're going to have 4x4s holding it up at each end using a 4x12 here. And this is not going to be a flush beam that's going to be in the ceiling. You can almost see here, if you can figure this one out, that if we raise this beam up to here, we wouldn't be able to have much of the structural integrity. The beam would be shaped something like this, and the engineer wouldn't like that. But I might do a video on that. Might do a few more videos on some options or reasons why you might not want to do certain things on here. And again, there'll be a complete playlist together when it's completed on YouTube, and I'll have a link to that in each video. And of course, I'll have a link to the web page where all of the information pertaining to this particular room addition will be also. So there's the beam, the end of it. Get a view of it here underneath the gable truss. Come to the other side. Another view of it here. Go to the bottom. And again, we're 3.5 inches in because we're going to want our wall framing to die into this part right here. So don't forget that. If you, hey, I'm gonna run it back to this beam and cut the framing plate off, probably not going to want to do that. Might not be a big deal, but we don't want to do that. Go ahead and frame our walls. Try and do it that fast out in the field, huh? We have our midspan blocking, trimmers. let's go ahead and zoom into putting a strap. And you can strap this in a variety of different ways. I'm just simply putting a strap on top of here and bending it over at a 90-degree angle and then tying it into the beam to get a nice plate, framing plate to the wall connection. And then you can always put another strap down here to connect the beam to the post. And you could always use the column caps. And then we have a strap here connecting the beam to the wall framing plates. You can always put another strap in here. The engineer is probably going to want a large 4-foot strap in here. And again, since I'm not providing product information, just keep in mind that this might need to be 4 foot long. And I just don't really get what the deal is with those long straps. And if this right here is smaller than 4 foot, by the way, you might need to put another strap on this framing plate also. Again, I'll put more of that information in some of the videos. I want to kind of make make a few other videos about some different problems you could run into with this particular design. Now, you're probably wondering why this block is low, and it's for the electrical box. If you're going to have a light switch here, then make sure that the framing blocks, the midspan blocks, are out of the way. I always like to lower mine. Some people want to raise them up, but if you think about the door, if you put these blocks in the middle of the walls, we have 8 foot, so these are at 4 foot, and we raise it up. We're not really providing much support for our framing. When we lower it, it's more in the middle of the opening than it would be if we raised it. Just another thing to think about. And then the blocks coming around, anchor bolts, our window opening. We have a 3-foot window here with a corner window that's going to have trimmers in it. Trimmers at each corner. 5-foot window here, blocks coming all the way back. View of the outside. What the corner windows would look like. And of course another strap here tying everything together. And this strap right here not only connects the framing plates together, but it kind of sandwiches the beam in between that also. And of course you can nail each one of the framing studs on each side to the beam and the post. Take a look at our anchor bolts. Remember, they got to be 12 inches or less away from each break. So if you don't have one on this side, which you would, I just don't have it on there because it was part of another project. If you don't have it on there, you're going to have to probably put one on. You'll see what I'm talking about here in a second. 5-foot opening. Anchor bolt by the edge here. And then usually less than 6 feet on center is the maximum for anchor bolts. By the corner here, these are positioned nicely. Same thing over here. And here's what I'm talking about. If we come around here and we cut our sill, and we might have had an anchor bolt over here, and we don't have one within 12 inches of the break, there's a very good chance that the engineer is going to want you to drill a hole into the concrete and put some type of an epoxy bolt in there. So another thing to consider. And this about wraps up our video. Once you have it in this stage, you can remove your support braces if you feel comfortable that the building's not going to fall down. And in the next video, I will go over the roof framing. I was going to try and put it all in one video, but it would have been a 1-hour video, it seemed like. So we will put that in the next part of this series, and that'll probably wrap up the series, except for the additional videos I make on some of the other pointers, or pointing out some of the other problems or things that you might want to change in this particular room addition. Well, welcome to part 4 in our video series on how to build this particular type of home addition. And first thing we're going to do here, in this one we're going to be working on the roof and the ceiling and the sheathing fascia board. And first thing I want to do is find the center of the building. Now, I'm not in this video here, in the purpose of these video series is to provide you with different ways to build something, and a few ideas in there on maybe why you might want to do that. And this one here, you can order a truss roof for it. You can build it in a few different ways. But here we're not going to use the standard method for figuring the roof rafters. We're simply going to find the center of the building and come straight up. We're going to come up here. You can use a plumb bob or a level to find the center up here at the top of the rafter. And again, this is a truss system on this house. And here we have the end truss, the gable end. And I have to point out that I have conventionally figured. I've figured the conventional roof rafters for a situation like this, and been disappointed that the roof truss, let's just say I thought it was a 5 and 12, was like a 4 1/2 or a 4 3/4 and 12. So if you are working with a situation like this, you can figure the roof rafter. Just make sure you double check it. You can use math to figure out the height here, or you can measure it. You can measure from here to here and use the roof rafter formulas for figuring roof rafters, or you can just simply measure it, which would involve pre-cutting the seat cut and the fascia board into the fascia board, something like this, and getting it to where the top is even. Now, I am using a 2x6 because that's what the span would probably work. I don't think a 2x4 would work for this. The 2x4 for the trusses actually has some type of a support where the 2x6 isn't going to have that. But the 2x6 is running past the center of the line here. And we're going to mark the center and then cut it so that we have our first roof rafter. And then we're simply going to cut another one. We're going to use this as a pattern and cut a second roof rafter here. And then make sure that everything is working out. This rafter is going to be the main, you're going to have to make sure this one here blends in with this roof. If for some reason you were to cut this rafter and this rafter was going to need to be an inch longer or an inch shorter, you could readjust the measurements to make it work out accordingly. You could move this over a little bit. Or you could just simply leave it as it is. Who's going to notice a 1/2 inch or an inch on a roof like this? And that's kind of the beauty of this system here. So you might not have the same size on each side of the roof, but it's really not going to matter for your home addition. So I need to point out that the rafter is even with the top of the framing, but it's not going to be even with the bottom. We have a 2x4 here and a 2x6 here. So to make everything blend in, we're going to go ahead and cut the rafter tail down. We're not going to cut the 2x6 rafter down, just the part that sticks over for the overhang so that everything will look nice and blend in. And pay attention, because I'm actually on this rafter here, I'm going to cut it. I'll shape it later on in the video because I don't need a double rafter here. And at the very end of the video, you'll see why. So here we have the rafters lining up, but we need to install a ridge. But before we do that, we will go ahead and move the rafters over a little bit. And we can always use some screws, screw them into the fascia board here. And then we're going to use this to mark the fascia board. And to do that, all you need to do is grab a 2x4 and then mark it. This is going to give you a little bit of room so that you can install your roof shingles underneath this area. If you're going to be using tile, this might need to be cut a little further, but you can always do this later. But if you're not and you want this to be closer, then you'll have to figure out what that is going to be. Usually 1.5 inches or something like this works out pretty good. And then we will simply cut the fascia board and then move the rafters back so that we can now start working on deducting the rafters for the ridge. And since the ridge is going to be a 2x8, we will simply deduct 3/4 of an inch off of each one of the rafters. And you can do this before. You don't have to do it in the same order that I'm working on it here. It's just sometimes it's easier to use these rafters without the ridge cut to fix the fascia board here. So then you can install the rafters on the other side and the ridge. Now, you don't have to do this part first. If I was going to do this, I would install my ceiling joist first and then throw some plywood on top, some of the roof sheathing I'd be using, put it on top of the ceiling joist, and then start working on my roof. That way I could have an area that I could walk on. So that's just something else to consider. Again, I'm not building each one of these examples the exact same way. I'm trying to give you a couple of different methods or some different ideas of what's something that might work for you, might work a little better. So here we have the ridge and then 4 rafters cut. Do not use your pattern. Make sure that you put like I always put the number P on it, or put a pattern in there. Write the word pattern on it. You do not want to install your roof rafter pattern and then realize that it's installed. You're going to have to take it back out or cut another pattern. So that advice right there is probably worth the time you spent making it this far in the video. Next up, we will install the ceiling joist. They'll be 16 inches on center. And you can see here where we have cut the one rafter here. I cut it so that I could take the block and nail it up against here. So we don't need a double rafter here, but that's not going to be a big deal. If you install it to where you have 2 rafters on the overhang, it's really not going to be a big deal. Trust me, not going to find too many people that are going to notice that. But you might need to shape the top of the ceiling joist. And to do that, you might have to have a rafter in place so that you can mark it and then use one as a pattern to cut the rest of them before installing them, obviously. Not a good idea to cut these afterwards. Better to have them cut, otherwise you're going to be walking up here. I'm not saying you can't do it that way, but if you can, cut the ceiling joist, cut the edges if they need to be cut, and then install them. 16 inches on center, like I said, 2x6. There goes our roof rafters. They are going to be 16 inches on center also, and they will connect to each one of the ceiling joist. Next up on the list, we will install the gable studs and the ceiling backing. Now I left 14 inches in between the center here so that we could put a gable vent in there. You can always have a board underneath here, a brace support board underneath the ridge if you're not going to put a gable vent in there. But a lot of times you're going to need ventilation for your ceiling in your home addition. You can always do that with a roof dormer vent also. 16 inches on center, and if you notice, I didn't have it. I had this cut off previously, but you want to have the ridge extend past to support the fascia board, and that's usually going to be 12 inches. So the distance from here to here would be 10.5 inches. Then when you put your fascia board on, the overhang would be 12 inches. But again, it's not going to be a big deal if you make that a little longer or a little shorter. And you can see here where the gable studs are lining up to make the end of the wall nice and flat. Take a look at our ceiling backing, a 2x4. Look at it from inside here. 2x4 just would nail to the gable studs. View of the corner. Now, if you notice the rafters here, I don't think the engineer is going to have a problem with this. But again, you'd have to check with your own engineer. These are just ideas. You can't take and build a house like this anywhere around the world and expect, hey, I did it from a YouTube video. No, I'm sorry. These are just examples of possible methods And of course, things that I've done in the past. I have actually done this before in the past and had the seat cuts extending past and then nailing to the ceiling joist. Never had a problem with it. Now let's go ahead and put the blocks in and the fascia board with our lookouts. Fascia board here is going to be, we're going to cut it back. I think the fascia board came to about here, so we cut it back to here so that we could nail it into a rafter, get us some nice solid nailing. And now you can see here where the block is that I have. This rafter came and it stopped here, and I nailed the block. This gives it a nice finished look at the when we look at it from the underside after it's all completed. Everything's nice and flat here. Wanted to give you an idea of what the corner might look like, and the fascia board might need to drop down. We need to line, if you were to set a straight edge on top of the rafter, then the line would come to right here. So if you're going to be installing your fascia board, that's going to be a good idea to use some type of a straight edge to make sure that the top blends in. If this was going to be, the edge of this board was all the way to the top, it's not going to look very good. And of course the bottom, it's not uncommon to have a bottom cut like this from the angle of the fascia board when you're coming into a horizontally level fascia board, and then you have one matching the roof pitch. Now I wanted to point out that I provided you with two different examples. Here we have a lookout that is at the bottom here, and here we moved it up a little bit. And my reasoning for doing that was to give you an idea of how this could actually weaken the overhang here. I mean, if you see when we cut it here, we only have 2 inches here, where if we move it back, we're going to have a stronger part of the roof rafter here. But if we cut it here, this right here might not provide us with a nice structural or enough strength, I should say, with these 2 rafters here to create a strong enough corner on the roof. And this could actually break. If it was to break, you were using roof tile, for example, and longer overhangs. Let's just say that I had a 30-inch overhang or a 3-foot overhang, and then here I had this going out 24 inches. Something like this would definitely be a problem. If the fascia board was back about 12 inches and we had the fascia board here was even with, it was basically just 1.5 inches overhang, maybe with a 3/4 inch spacer between the fascia board and the roof rafter, then it might not be a problem. So here's one way to look at it. If I take and move the lookout up a little bit, then I got a lot stronger section of the roof there. And then the fascia board here butts in. Now, I'm not going to go into a lot of detail about finishing this, but it's not a bad idea to put some type of building paper in between. You want to make sure that it is attached to the building, to this wall here, and then nail your rafter into it in your fascia board. That way you create somewhat of a watertight area here. If you don't do that and someone comes in and they finish it, you could have some gaps in here and end up with some water leaks in the corner. Next up on the list, we will install the roof sheathing, 1/2 inch OSB, and I did this side a little different than I did this one, of course, to make some points of what your engineer might want to see. And if you remember, in one of the earlier videos, I pulled off the whole sheet of plywood. I think it went from about here over, and that's so that I could put a full sheet in here and then create a nice tie, nice structural tie between the 2 buildings. If you have a situation like this, or if I was just to use the existing sheathing and then install the new sheathing in it butt up against here, then you might need to install some type of straps over the roof sheathing with some blocks, even with the bottom of the roof sheathing, and then nail them to it to tie the building together. Another problem you could have, your building inspector might not want to see a small strip like this, so you might have to do something like this. So you're going to have a little more waste, but 24 inches would be the smallest piece here. And this, of course, would be larger than 24 inches. So something like this would make your engineer and your building inspector happy. So pay attention if you have a set of plans. Pay attention to this. I know a lot of people, they go in and they nail all their sheathing down. They do something like this. They put the little strip in there. Then the building inspector comes along, pulls out the plans, and then schools you on it and reads to you where you should have read this before. So make sure you read all of the information you can in the building plans, especially when it comes to this right here. Now, if you remember, I didn't install any collar ties. You can always use straps. And again, that would be something that, if it's on the plans, you might not have an option to install collar ties. The engineer might want straps. And if that's the case, the straps are going to nail over the rafters. And these ones here are spaced 32 inches on center. Yours might need to be 16 inches on center, depending upon the engineering. And here's an example of the fascia board that we cut. Here we now have a 1-inch space between here, which would probably work out fine for composition shingles. And then you would roof underneath that. So your roofing materials would go under here. Now, if you notice, I have a 1x4 here. This is going to be so that you can install some type of metal for the waterproofing. I say waterproofing. I don't like to use that word. Water resistant. It'll get a piece of metal here, and then and this will all depend. If you have a stucco wall here or siding, then you might need to cut it. This to tie it into the building on this side could actually take you a few days to do it, to complete the whole process. So this isn't going to be something you're going to be looking forward to. But there it is, your Z-bar backing, your home edition, and now it's ready for framing inspection if we got everything on the plans. And as I promised, this right here gives you an idea of what we did when we cut the rafter here so that we could install our block over it instead of having the double rafter. That is it for the video, and I don't know if that's it for the series. I'll put a link somewhere in the video or a link in the video description box to the any more videos that I make on this particular building design. Here is another video that is the result of someone else's question. They wanted to know how you could build a room addition with a angled section. And of course that would look something like this. And you're probably thinking, why would anyone ever want to do this? But I have actually worked on projects where there was a tree that someone didn't want to remove, and or maybe it was next to a building, something like that, someone else's property. That's pretty common. One time I remember working on a house down by the beach where the lot, let's say that it was 30 foot in the front and 20 foot in the back. And they built the house right up against the property, and it was shaped kind of like the lot. And it was difficult because I had to put a set of stairs in, to make it work. And it wasn't very easy. It didn't look that good when it was done, but that's not what we're going to run into here. The angled wall is at a 45-degree angle. Plates there. And of course, if you do cut your corner like this where both of the top plates don't lap, you're going to need a strap. And you might even need a longer strap. Bottom, same cut. And again, I'm going to kind of throw in a couple of different cuts throughout the video here to give you an idea of what you can do. Just give you some more options on how to build things. So here we have it here. This framing plate butts up against this one. So it's cut at a 45-degree angle. It's not mitered. The other one was mitered at a 22.5-degree angle. This one here is going to be a 45-degree angle on this one, 45-degree angle on this one, and then the top plates will simply lap. So this one butted up against this one. So this one ran through, and then this one here is going to run through. Get an idea there, and you just simply nail these plates together, and that creates a nice tie. So hopefully that makes sense. Now I wanted to show you this. This really isn't that big of a deal, but if you have a square plate, you just want to square it off and then cut a 45-degree angle. This isn't going to be a big deal. You can finish this off still by taking a framing stud and then bringing it over if you wanted to, or cut one at a 45-degree angle to where it would run this way, and you could fill this area in. Not going to be a big deal to finish that if this is going to be easier than doing this here. Next up, let's go ahead and install the ceiling joist. 16 inches on center and a 45-degree angle cut here. And these are not going to need to be shaped like this here because the rafters are going to be a little higher here. That'll make more sense in a little further along in the video. Now, this is just a way that I think is going to be a little easier. And this is actually how I would build this myself. I would put some type of a straight edge underneath the rafters, set it on top of the ceiling joist, and then I can use that to support my rafters temporarily so that I can mark and cut them. Just really seems like a easy way to do it. And if you have a longer section, you might need to use a 2x6 or a 2x8. Make sure the board is straight, and you might need to put some type of a support leg or support brace underneath it to prevent it from sagging at the end. This section right here seems like it would be fine like this. It's only cantilevering off this far here. Everything else is supported. And then we're going to just put our rafters in. Of course, you're going to do this one at a time. You won't need to install all of the rafters. You can. Feel free to, you're going to temporarily support them to the ridge, set them on top of your straight edge. And you can see how this, hopefully that makes sense. And but again, I think something like this, just doing one at a time, setting the board up and connecting one of them to the ridge and then marking them accordingly is going to be about the best way to go. So let's go ahead and remove the other rafters. Do one at a time here, put it up to next to the ceiling joist, and this one you're actually going to be able to nail into the ceiling joist to create the tie going across. And you might actually need to do some modifications if your ceiling joist rafter ties, or the ceiling joists you're going to use as rafter ties, won't work. And if you have any questions about that, go to the website, go to the framing section under the home building framing, and then go to the roof framing and look for rafter ties, get some more information on that. So let's go ahead and put our first mark here, and we're simply just going to use a straight edge or a level and come up and draw a line here. Put our board back there, just kind of giving you an idea here of without the ceiling joist what we're going to need to do. Same on the other side. This is going to be a plumb or vertically level line. And again, these are just going to be reference points sometimes. You're not going to be actually cutting this, but you might need it as a reference point. So hopefully that makes sense what we're doing. And then you can connect the lines on the top and the bottom. And now you have an idea where the wall is going to be positioned here, and you can use that for your any cutting, notching. So for example, if I was going to cut a seat cut on this one, instead I'm going to put a block underneath it. I'm going to angle the block. But if I wanted to put a seat cut on this, I could take the rafter down and then cut the seat cut and then set it on top of a square block or a block with 90-degree angles all the way around. but we're going to use a shaped block. It's going to have an angle at the top of it. And another thing you're going to have to think about is whether or not you need to cut the rafters down. Here we have a 3.5 inch wide overhang, our rafter tails. We have a 2x6 rafter that needs to be cut down. This is all something you can do with these reference points when you are shaping the rafter before you install it. So put the rafter in. You're going to use some screws to attach it to the ridge. Maybe use some screws to temporarily attach it to a board, maybe the ceiling joist, even the straight edge to prevent it from moving. And then you could mark everything out, pull the board down, and cut everything that you need. Now, I want to point out here, I just took this angle. I did not run, or this block, I didn't run it parallel to the wall here. I brought it over here. This isn't a block. This block's going to be more for, you can nail the plywood into it, the roof sheathing, and then attach it to the framing plates. It's not going to be used for any type of backing or anything. So I just kind of threw out another idea there. I shaped this block so it can nail to the top of the sheathing. And so we have a couple of blocks that will nail. This one here can always be shaped to, for that you can always, if you can always put if you need a 2x8 and then another 2x8 on top to shape the blocks also, and you can connect those together with some straps if you were worried about it. And of course the gable rafter here, we have our gable studs supporting it, and of course I have the square cut on the bottom here. I was kind of giving you an idea of if I was to put a level cut on the bottom here, I could use a square board to support any one of these rafters. That could be done on all of these rafters, by the way. Get an idea of how the roof sheathing would tie to these two boards. Next up, we will need to install our eave blocks. And this is probably going to take you a little bit of time to do something like this. Going to have to figure out the angle of the cut there. And not going to be that difficult, but might be a little trial and error stuff to do there. A view of it from the bottom. And here we have our blocks so that we have some backing in case we need to nail siding or our lath for our stucco to. We're going to be able to have something to attach it to. That's why we have the different sized blocks in there. Now let's go ahead and take a look at our fascia board. We're going to have a 2-foot overhang here, and then for the gable end we have a 12-inch overhang, and I'm going to have a 12-inch overhang coming off of here. You could always have a 12-inch overhang, maybe a 18-inch overhang, and a 2-foot overhang. There's no specific rules for something like this. You just have to make sure that the rafters and the fascia, the cantilever, will actually support the load that would be transferring from the overhang to the building. So give you an idea here. And another cut that I did, you could have a square cut here like we did over on the framing. Square cut and then a 45-degree angle. Only problem with that is you're going to have something like this on the inside. And if, from the outside you're fine, this is going to be easier, go for it. If if not, you can miter the other side. I have it mitered, 22.5-degree angle kind of a thing. Take a look at it from the front there. And like I said earlier, we're going to have a level board here, and then an angled board here, and then an angled board up here. Put our sheathing on. Take a look at it from the side there, and that is it for this video. So hope it helps. If there are any things that you have questions for specific sections of this video that I did not explain, feel free to leave your questions in the comment area and I will answer them as soon as possible.